All right, guys, I need you to go get your calculator. Don't come back until you have your calculator in hand. Pause the video, get your calculator, and come back when you're ready. Okay, hopefully you're ready. So here's what I want you to do. I'm going to give you a number, and I'm going to put a number here, and you're going to go sign of that number, and you got to tell me if it's true or false. So let's get this started. Type this in. Type in sign of 90. Do you get back 1? Yes or no? I'll wait. Type it in. Turns out it works. We'll keep it, okay? Let's try this a few times. Why don't you go sine of 450? True or false? If you're keeping up with me, it works, doesn't it? It works. It's good. What about, I don't know, sine of 500? True or false? If you're keeping along, it's trash. It's no good, right? So we throw it away. What about sine of negative 270? Would that be true or would that be false? Type it in. It turns out that it is true. Keep it, let's leave it there. What about a couple more? What about sine of negative 90? Would that be true or would that be false? Well, what does your calculator say? Does it say 1? No, it doesn't. So that's trash. One more. Sine of 810. Type it in. True or false? It's true. Okay. So, what was the goal? We want to find all angle measures that work for this equation, but those angles have to be between 0 and 360. Well, all 4 of these angles, they work for this equation, but are all of these in between 0 and 360? No. The only one that meets that requirement is actually just 90. So for this first problem here, the answer would be 90 degrees. And that's it for that one. But notice the comparison between the two problems. Here, your answers are between 0 and 360. Do they mention anything here about your answer having to be between 0 and 360? No. They say find all angle measures that work for this equation, period. This said find all angle measures between 0 and 360. So if you were to remove this condition, if I were to just lift this off and throw it away, then, which is what this is doing, then what's happening is you're just opening the door and all kinds of angles have now joined the party. Specifically, these ones here. This works, and these work. All of these angles work for this equation. But do you think that these angles are the only ones that work? Of course not. There are many others. And we can find all of them, and it won't take us that long. So let us consider some patterns here. How do these angles compare to 90? What is the relationship between these angles and 90? Well, check this out. I'll just type it in here, I guess. I'll just write it in here. How much is 90 plus 360? You should have a calculator. Type this in. What's 90 plus 360? Turns out that it's 450, which is right there. How much is 90 plus 360 plus another 360? Type it in. You'll see that it's actually 810, which is right here. So what's happening is we're finding coterminal angles. So I can add 360 once, or twice, or 3 times, or 3 billion times. You keep finding coterminal angles to 90, and they will satisfy this equation. But not only in the positive direction, we can also go in the negative direction. Let's go 90 minus 360. That gives you back negative 270, which is right here. And that's why negative 270 was the solution to this equation. So we can add or subtract 360 as many times as you like, because all you're doing is grabbing all of those angles that are coterminal to 90, and they build or they constitute your solution set. So to summarize all this, for this equation here, we say that all the angle measures that work, they originate from 90, but from 90 we can either add or subtract 360. But not just once. I can add or subtract 360 once or twice or 3 times or a billion times. So for that reason, I attach the letter n, because that means that from 90, I can add or subtract 360 as many times as I feel like doing, okay? So that is the key difference between a problem like this, which has no restriction on your angle, and a problem like this, which does have a restriction. So the one that has no restriction, it's pretty much the same answer as before, 90, 90, but this would have plus minus 360n. If the whole problem were in terms of radians, it would have been plus minus 2 pi n.